Okay, I'm going to go ahead and get us started with this week's edition of the Spatial Analytics and Data, or SAD 2020 seminar series. Before we get started, just a few logistics. Our speaker this week will talk for about 30 to 40 minutes, which should leave us plenty of time for questions. If you could use the Q&A functionality of the Zoom webinar to post your questions, that would be fantastic. And actually, it's possible to upvote questions that you see on the Q&A. So if you see something you like, please feel free to upvote. And you can also tweet, of course, using the SAD 2020 hashtag. I've given mine and Levi's Twitter handles at the bottom of this slide. And I think then, without too much further ado, I'll get us going with this week's speaker. So we're very pleased to welcome this week Anna Moreno Monroy, who is an economist at the Center for Entrepreneurship, SMEs, Regions and Cities at the OECD. She was previously a visiting assistant professor at the Autonomous University of Barcelona and a Marie Curie Fellow at the LSE and the Rovira i Virgili University in Spain. She holds a master's and PhD in economics from the University of Groningen in the Netherlands and is an honorary fellow at the University of Liverpool. Her research uses geospatial data and economics and geographic methods to help design social inclusion policies. She's published in leading academic journals, including the Journal of Transport Geography, Urban Studies, Spatial Economic Analysis, and the Journal of Urban Economics. It is our great pleasure to welcome Anna this week. And so I'm going to stop sharing my screen and turn it over to Anna.
Thank you so much, Rachel, for that introduction. Let me just go ahead and share my screen so we can get started. Perfect. You can see my screen, right? Great. It's a pleasure to be here, and thank you very much, Levi and Rachel, for the invitation. Today, I'll be presenting some ongoing work that we're doing together with colleagues at the Joint Research Center of the European Commission in ISPRA, Chris Jacobs, Crisioni, and Mer Kompil. Chris is actually here in the room with us. So I'm glad for that because he can also help me with the questions later. And for this project, we had a simple question, and it is, how much more expensive is it really to provide services in rural areas? For my work, I work with rural areas mostly, so we were interested in the question of quantifying the delivery of services, especially in view of future demographic change. So actually, Chris's team at ISPRA has produced these nice maps that show us the changes, expected changes in population from here until 2030. And you see there are two maps for two different age groups. The one on the left is for those aged between 5 and 19 years old, so school-age kids and adolescents. The one on the right is for people over 65 years old. So you see that sea of blue means all the areas that are expected to lose school-age kids from today until 2030. And you see that change is strong, is happening all over Europe, but it's also not uniform within countries. Obviously, this has a strong rural-urban component. We see some rural areas that are far away from cities losing disproportionately school-age kids in the next decades. On the other hand, the red that you see on the right corresponds to areas that are experiencing faster aging. And this also relates to the availability of, for instance, workers such as teachers and healthcare workers. So with this in mind, of course, we think that in the next decades, many areas in Europe are going to face a strong change in demand for services, specifically for education and healthcare. And in this presentation today, I will focus on the question of the changing cost of education following these population changes. We are working separately on the question of the changes on healthcare costs that relates to the aging processes. So basically, what we're going to present today is supposed to be a tool for policymakers on to how to plan for the future. So we know these areas are going to face population change, student numbers are going to change, they need to adapt the school network, they need to plan for the future. So the first step is to identify which are those populations that are more vulnerable to losing accessibility to services, specifically schooling, which are those that are facing under provision and will face an even stronger trend in the future. For this, we wanted to specifically contribute to the estimation of expenditures, because once we tell governments in the future, you can expect your school costs are going to increase by this much, this already gives a more direct answer to the question of what should be done under different policy scenarios. If I change this or I change that, how is that going to affect my future costs, and what do I need to do today to prepare? So basically, you will see that today what I will be presenting to you, it's a model where we can give some clues about these future changes in different territories in the European Union. I will be referring throughout the presentation to something called the degree of urbanization. Here I make a parenthesis before going on. Probably many of you are familiar with this, but for those that are not, this is a grid level classification that the European Union uses and is basically based on the population density at 1 square kilometer grid cells and the contiguity of these grid cells. So they classify the whole of the Earth's territory, not only Europe actually, into those classes that you see there that range from urban centers all the way in density levels down to very low density rural grid cells. You see there, the lighter green corresponds to more rural areas, the red clusters corresponds to urban areas. So you see in the table at the bottom that rural areas, of course, comprise most of the territory, the land, but a much smaller percentage of the population because most people are concentrated in cities. But this is going to be important for understanding how the placement of services works, because services still need to reach those people that are spread out in rural areas. We can reaggregate these categories, and I will be showing now that there are 6 categories there. I will be reaggregating them to tell you a simpler story, but this is basically a very flexible classification of territories that allows for equal comparisons across countries. So using the same definition of rural urban. So now moving on to the next part of the presentation here, I will be telling you about the method we designed for estimating the present and future school costs. After this, I will be giving you an example of how this method fared for the case of Portugal. And after that, I will be presenting you the results for EU-wide estimations. Before I proceed, if there are any questions, Rachel, let me know because I cannot see the Q&A, but please interrupt me. I will be stopping in every one of these points in case there are any clarification questions. Please let me know, otherwise I will continue. Okay. So far, so good? Perfect.
So far, so good.
Great. Okay, so with that introduction, I hope it was clear. Now I will be moving on to this part where basically I come back to the initial question I posed to you. So it's how much more expensive is it to provide services? Why do we know it is more expensive to provide services, or at least more complicated? We know that this is because rural areas are sparsely populated. They don't have high population volumes. Therefore, they face higher transportation costs because people have to move further distances to reach facilities. These facilities are going to be smaller in scale. That means that they have lower economies of scale and scope, and therefore higher costs. And on top of these, rural areas many times have to offer financial incentives to attract and retain professionals, therefore adding an initial layer of costs. It's important to understand that the small facilities are there because they need to be accessed by people. Of course, concentrating facilities in space would reduce the cost, but would increase the distance. So small facilities basically serve for an equity purpose, meaning that people can travel a certain distance and still access the services. So there is this intrinsic trade-off between the economies of scale on the one hand and access or transportation cost on the other. Taking this trade-off into account, we're gonna be basing our estimations in 3 basic principles. The first principle is that the costs, as we are going to understand them here, are the ones that arise in each facility. In the case of education, in each school. These costs do not arise in areas per se. So in schools, districts, or in municipalities, etc., they belong to the facility. These facilities, as I mentioned, need to be provided close to residences. So that we are speaking about local services, services that are accessed physically by users and within a reasonable amount of travel time. And that because, as I mentioned, the small scales, there's gonna be some what is called unavoidable costs of smallness and remoteness, meaning because these facilities cannot exploit these economies of scale and scope, they're gonna face higher costs than larger facilities. So now as to how do we distribute the facilities, how do we allocate them? Basically, you see there an animation of how we proceed with this problem. We know where, as you saw from the map in the introduction, we know where the school kids are all over Europe. We know their age ranges at the 1 square kilometer level. Therefore, knowing where the demand is, we can allocate facilities according to some bounding conditions. Once we allocate these facilities, we assign users to the facilities. And the idea here is that we are maximizing the accessibility for the country as a whole, but our accessibility model has some component of equity, meaning that we're giving a higher weight to the person with the least accessibility. If we didn't do this, we would end up with very large, very efficient, relatively cheap schools, but students traveling very long distances. So the way we ensure that there is school provision everywhere is by adding this equity component into our accessibility model. And I'm sure if people have questions about this, also my colleague, Chris, who is in the room, will be happy to take some of your questions regarding the specificities of this allocation model. Once we have the schools with the students, we proceed to estimate the school costs. So how do we do that? We know where the schools are, and we know how many students are in each school. So our problem was, how do we go from that to how much expenditure there is in each school? So the first thing we did was to source data from actual schools. What is the structure of the expenditure? And we were lucky to find data for the United Kingdom, specifically England, where you have for each school in England, what is the structure of their expenditure. So you know how many students are there, how many teachers, and what the school spends money on. And you see the table there on the expenditure structure for primary schools. Two interesting things in this table. The first one is that almost 60% of the expenditure of schools is on teaching staff. So this was the first clue to our problem. We said, if we can figure out how many teachers are needed in a school, and we more or less assign them a wage, we're halfway there basically on estimating the costs of the school. The second interesting part of this table is that you don't see any geographical differences in the structure of the expenditure of schools in England. Usually when I do this table, you know, there is a nice ordering of things where things in cities are cheaper and things in rural areas are more expensive, for instance, or there are geographical differences. But here, actually what this is telling us is that the establishment of the school as such on the mean has the same structure in a rural and an urban area. So there is nothing intrinsically rural that changes, let's say, the basic working of the school in the sense of distributing their expenditure between different categories. That is actually good news for our model because we can then model facilities and then let the data give us the rural-urban differences without having to introduce any specific rural component, let's say, that differentiates per se a rural or an urban school. And this is what I mean by before when I mentioned that the costs do not arise in the areas per se. So there is nothing in the rural area per se that makes the school more or less expensive. Then after that, because I said, if we can figure out the number of teachers, we're halfway there. So how do we do that? We have a very important component for schools, which is the pupil to teacher staff ratios. It tells us how many students can each teacher takes. So you can imagine that from the number of students, we can figure out how many teachers will be needed in the school. And the other nice good news that we saw when we started analyzing this data for England is that the pupil to teacher ratios actually are pretty well behaved. They follow a normal distribution, as you can see there. And this distribution is very similar across different degrees of urbanization. So that already was very helpful in our problem of how to assign the teachers. What we did was to then draw a random distribution of the pupil to teacher ratios, which we center in average values for EU. And this is because our aim is to try to understand the cost differences in school provision across European countries that are driven by geographical differences and in the future by population changes and not by any other institutional factors. So of course we know that, for instance, the pupil to teacher ratio is much lower in Portugal than say the UK or the Netherlands, but that's not what we want to capture. So we set it to the EU average. We draw random values from a normal distribution with mean this, and then we know that if we order the schools, smaller schools get assigned their pupil to teacher ratio, then from this we can very simply define the number of teachers. And I know this doesn't sound like a very fancy method like the ones the public of this seminar is used to. There is no machine learning or mind-blowing data crunching, but actually it's very effective in reproducing what we want to reproduce. It's very flexible. This approach is probabilistic distribution, nothing fancy, but actually because the school data is not so complicated per se, these are very basic units. You have your students, you have your teachers, scale economies behave like any economist would know. Then this approach works very well in reproducing the patterns that we see in England, and also works for extending it for other countries. I have to mention that at the beginning, we tried, for instance, regression analysis to try to tackle this problem, but actually it's then more relevant the question of how much the cost of the case of the UK applies to the whole of Europe, for instance. Whereas here you see this is basically very, let's say, simple in a way, but it doesn't depend on any UK specific parameters. Because it's all drawn from the same distribution. So after figuring out the number of teachers, we assigned some expenditure. So that means we assigned some wage structure to the schools. We did this by first checking how many more staff is needed after you have the teachers. The teachers have their teaching assistants. There is also a proportionality with the non-teaching staff. So we populate all the staff of the school, and based on some values that we could get from the literature or from the UK, we set wages in a way that more or less reproduce the expenditure patterns that we saw in schools. And then also locally, things like expenditure in IT equipment, catering, all sorts of stuff behaves linearly with the number of students. It's very simple. So we use this simplicity to reproduce basically the data for England. And the check that we did, what we're interested in is if with this, say, simulated approach, we could reproduce the differences, the geographical differences that we actually observed for England. And here in the table, you see this is the mean center. So the 0 is the national average for England. This is how much more expensive or cheaper expenditure per primary school student are. The blue bars are the actual data. So you see there, it's about, the largest difference is about £1,000. So it's £1,000 more expensive to provide a kid in a mostly uninhabited area compared to town in England. The orange bars are our estimates that are based both on the method that I just explained and the placement of the schools. So you see there, we capture the geographical differences. And the trick here, actually, because if you remember, there is nothing rural on the estimation per se, so you might be wondering how are these differences actually captured. And the whole trick is about the percentage of small schools that are in each type of area. So actually what is going to determine largely, not to say mostly, the geographical differences in cost that you observe is the fact that in rural areas you have a larger proportion of small schools that run possibly below efficient scale levels. So you see there, for instance, this percentage is around 80% of schools in mostly uninhabited areas. So our approach comes close to reproducing the actual percentage of all schools that are small. And this is all by distributing students, like I explained, over territories with our simulated facilities. So once we got this right, we are pretty confident about applying this method to other countries because, as I said, it doesn't depend on anything English specific, and we are not directly, including any parameter to hint rurality. Here you see two other checks that we did. On the right, you see the actual placement. You see the nice scale decrease. So as you increase the number of students, the expenditure per student decreases. Of course, when you plot this for secondary, the decrease is maybe slower. But what we managed with the simulated placement is to reproduce this pattern. And also what is interesting is that in our simulated approach, we're also able to reproduce some of the variation that we see, because this is going to be important. You see the mean differences are not at large, but there are huge variations within the rural categories that are going to be very important for us to understanding then the policy scenarios. Before I continue, are there any questions about this part? I'll be happy to take any questions up to now.
I think that you're still good so far. We're just sort of collecting a few in the Q&A, but I think you can just continue. Okay, perfect. So now, hope you believe me so far, but I will show you anyway how the model fares when we apply it to Portugal. Portugal is a country where we know where the schools are and how many students they have and how many teachers they have, but we don't know the expenditure. So this is data that we cannot compare, but we can at least check if we come close to reproducing the number of teachers and the number of schools. Although it is not the aim, as I said, of the method to reproduce these numbers as such, but to understand geographical differences, it is also a good idea to check anyway how it fares comparatively. So you see there, the student numbers are pretty similar because they're basically based on the similar population input, so that we didn't expect many differences there. We come very close to estimating the number of teachers following this number of students. And we're happy also that we managed to capture the geographical differences in this number of teachers, which is the most important part for our analysis. In terms of the schools, it's the same. As I said, we didn't expect to reproduce the actual number of schools in Portugal because our model, as I explained, is based on an efficient allocation. We know that in reality, there are many things that can happen that would make it that you have many more schools that is efficient according to an accessibility criterion. This could be that there have not been a strong process of school closures
following the reducing number of students. It could be that there are barriers, so like school zones or no collaboration between municipalities of regions where students have to attend a certain school in the region or area, etc. So we already expected that our school numbers were going to be smaller, but we're happy that we can at least reproduce the geographical distributions of these schools, because this is quite important for us to understand the cost differences, which is our ultimate goal. If we look more closely at the distribution of both expenditure and the travel distance, you will see there that what happens in more rural areas or sparse rural areas and villages, you have slightly higher means, but far more dispersion, which is something that we saw also for the case of the UK. And in the case on travel distances, of course, you're going to have very compact travel distances in cities, as most kids can access schools very close to the residencies, but this is going to get larger and larger as you decrease the density levels. So you see here that from both sides of these trade-off equations, rural areas face both, in principle, higher expenditure, more variation in this expenditure per student, and higher travel distances. So this is going to be key to understanding what happens in the future as well. So as I mentioned, because we model the access of students to schools, we can actually get quite interesting information that we don't usually get from data that is ready for countries. We can track from which area each student travels to go to a school. So this allows us to understand a bit the inter-area flows of students. And it's actually quite interesting that a lot of the action happens within rural areas. So mostly students traveling, as you see there, in villages. You will have that 45% of kids that attend schools in villages come from other areas. Most of them, 89% of them, come actually from sparse rural areas. So if you think of, this is very important for us to understand, because if we're thinking of a reorganization into the future, we need to understand, villages, can they centralize more this provision for sparse rural areas? They seem to already be doing so. So is this going to change in the future? There are also some quite interesting things that change quite a bit across countries. For instance, how many students from cities go to suburban areas. But I will not comment a lot on that. So now that we hopefully believe that the model more or less works, or we understand at least how it works for Portugal, because we can track all the inputs of the model, let's say, to understand changes, we're going to play with two future scenarios. So we have population projections to 2035. So in 2035, we know how many kids of primary school age there will be. So with this, we're going to do two exercises. The first one is that we're going to keep the schools in 2011 fixed, and we're going to let the 2035 kids get to the schools. So this is assuming your population changes, your student numbers decrease, but you don't do anything about your school network. We will see how this affects the school costs. The second exercise is basically doing the same that we did in 2011 in 2035. So it's not like we're going to close 2011 schools, but we're just going to see what would be the efficient distribution of schools with the population numbers in 2035. And we're going to compare these two scenarios. Of course, we expect that the first scenario is, let's say, less efficient in terms of costs, because it will not be efficient for the student numbers that we already know are going to decrease in most countries. Because you already saw all the model inputs that we have, we can play around with a lot of policy scenarios that we can compare to this kind of school network exercise. We could see what happens if we increase teacher wages, if we increase the number of teaching assistants, etc. So I'm not going to discuss that. I'm going to discuss a specific case where we increase the pupil to teacher ratios and see what happens with expenditure compared to these two other scenarios. So these are the basic results for the changes. The first thing to notice is the strong change in number of students that Portugal is going to face. There's going to be a 30% reduction in the number of students from here until 2035. And this reduction is, of course, stronger in less urban areas. In our model, of course, less students means less schools. So you see there is around 19% decrease in the number of schools when we do the new allocation in 2035. If we compare the two scenarios, as I mentioned, then the population changes alone. So having less students in 2035, even though we efficiently allocate schools in 2035, leads to an increase in expenditure that is, of course, much larger in more rural areas, so around 6% in sparse rural areas and 4% in villages. This increase is about double if we don't affect the school network. So if we keep the 2011 school open, place the 2035 kids, the change will be around double. So this will be like the kind of inefficiency measure of not handling the school network, given that the change in the, given that the student numbers changed. You see there two plots with the shifting of the distribution between the two cases, the three cases, sorry, so the present case and the two scenarios for two different variables. And you see here again this trade-off that we discussed. So if you don't affect your schools, you're not going to affect the travel distances. But if you replace schools, this is going to increase the mean travel distances of students, especially in rural areas like is illustrated there for the case of villages. We will come back to this. This map shows you the huge variation that there is in the increases of travel distances that students have to experience once we reallocate facilities in 2035. And it's important to notice that many things may be hidden on the means. So here, this is where we talked about the mapping of vulnerable populations, because you see there that this kind of approach allows us to identify which students are going to face really very large increases in the travel distances following a reorganization of the school network. If you talk about a 30-kilometer increase for a primary school kid, that is really a lot. So this would be the trade-off of the policy. Yes, you have more efficiency on the network as a whole, but the people with the less accessibility are going to be strongly affected by these changes. And then you see there the summary for the changes in the travel distance between the two scenarios. Well, let me go to the policy comparison now. So we talked about the two scenarios and how that affects cost. Now I want to compare the scenario where we leave the schools in 2011 open, and we are going to increase the efficiency at the school level. So we're going to allow that each teacher takes 16 primary school kids on average instead of 13. So increasing school sizes. And if there are any education people in the room, I hope you raise your hand and tell me, yes, this has a possible effect on quality, which is something that I have not discussed here. So we'll have to take into account that this policy may affect educational quality. That is an extra variable that you would have to consider in this trade-off. Let's say for the sake of the exercise, let's imagine that it is possible that the educational ministry does a policy that allows for this change to happen. And you see there that this is a much more effective way of reducing expenditure than actually reorganizing the school network in a way. You see a much stronger change in the school costs following this efficiency change, but this change has a very different territorial pattern because it is much more effective in schools in urban areas. So we will be more effective in reducing expenditure in urban areas that are already cheaper than rural areas. And this is because it increases even more the scale economies that schools located in cities get. And through this mechanism, then they result in even lower expenditure per student on average in cities compared to rural areas. So it is an interesting exercise to think about the alternatives that you can have. You can imagine there are multiple combinations of spatial policies with educational policies that you can play around to understand what is going on with these changes. With this, I conclude the part on Portugal, and that I'll be really happy to take any questions, if there are any, or...
I think we're still fine. I don't know that you have a very economics-oriented audience that is used to posing questions throughout the talk. But I do encourage everyone to start thinking about questions they may have for the speaker following her talk.
How are we doing with time? Because I can check.
You're fine. I think you have about maybe 5-10 more minutes. Okay. And that would leave another 10 minutes for questions.
Yeah,
perfect. Great. Okay, so now that you saw the workings of the model for Portugal, we are able to apply this method for the whole of the EU plus UK. Sorry. And here you see the cost comparison across countries, which is also an interesting exercise. As I mentioned, these cost differences will be reflecting only the geographical differences of countries, specifically their human settlement differences. So if more people are located in sparsely populated areas, therefore leading to a larger proportion of small schools, therefore leading to larger expenditure per student in rural areas. And you see there for the EU, you have this nice arrangement of the less dense areas have larger costs. This is arising, as I said, from the share of small schools in each type of area. But you see there are quite a bit of differences across Europe. You see countries that we know have sparsely populated territories like Finland, Sweden, and Greece have much higher differences between their sparse rural areas and cities on average for expenditure per student. I have to mention that this expenditure per student is measured at place of residency, not at the school level. So we do this because in the future comparison, we actually want to check the effect of population changes, not so much the change in facilities. So instead of averaging the costs for each school, what we do is that we measure the cost of each student at each school, and then we follow them back to the residency, and then we do means of where students live in order to make a fair comparison in the future. So that's why you see there at place of residency. They are pretty similar both, but this is, we believe, more conceptually sound. So here, reproducing a bit the pattern that we already discussed for Portugal, you observe large differences in school access within countries, of course, rural areas. And I did not mention a lot the case of secondary schools, but this is an interesting case to discuss as well, maybe too much for one presentation. But of course, we allow secondary school kids to travel larger distances. So then the question of distance becomes more relevant. And also in future projections, you see more changes, and there are also larger variations across countries. So here you see the average travel road distance for both primary and secondary schools across countries. And you see there that the reality of kids having to travel long distances varies widely across Europe. So therefore, highlighting which countries give more importance to this topic, as many of them, it will be a problem really to how to reorganize the school network without affecting too much these travel distances that are already quite high. Now, for answering the question in the title of my presentation, how much will the cost increase in the future? This is a question we can answer with the model, of course. These are changes driven solely by population changes, as you hopefully could see from the presentation of the model. And here you see, first, before we get to that, understanding how much the number of students that have to be served will change in the future. We observe, because there is generally a pattern still of migration to urban areas across Europe in the projections, you will see that the process of concentration of population in urban areas will continue into the following decades. linked to this, you see that there will be an increase in the number of students on the average in the EU and a decrease in the number of students in more rural areas. But this is not uniform across countries. Some countries will experience far larger extremes of the same process, such as the case of Lithuania, or actually a reverse process, such as the case of Sweden. So this is when it becomes interesting, because even though there are general population trends across Europe for this group age, this already gives you an idea of how the scenarios will be different across countries. If we plot then, say, sorry, before that, you see here the absolute number for Europe. We're looking at pretty strong reductions in the absolute number of students and a larger concentration in cities. So it's basically, in summary, the situation for the EU plus the UK. Following this fall in student numbers, of course, there will be a fall in the number of primary schools, comparing our efficient allocation in 2011 with 2035. This will mirror the changes that you observe in population numbers, but already these differences tell you how much work is ahead of countries that have to reorganize this school network. And then there will be, of course, much different for countries facing much larger changes. Here we're talking for EU-wide. You can see there the absolute reduction in the number of schools between the two scenarios. For instance, in sparse rural area, we're talking about 3,896 less schools between the two scenarios. And it's actually not so much time between 2011, 2035. It's actually a big problem of restructuring of a network. On the other hand, there would have to be more schools in cities to provide for all those kids that are going to be living in cities in the future. And now finally, after understanding this, you see the change in expenditure, how much are expenditures going to increase. Here is euro values into the future. So you see there for the EU average, it doesn't seem like a lot, but this adds up because this is per head. And also you see interesting differences across European countries. It's actually interesting for new EU members that we already know are busy with the problem of demographic change, such as Estonia, Lithuania, and Latvia, that would have the stronger differences, especially because of the loss of population in rural areas that is happening much faster than in other countries. And finally, to conclude, this would be the comparison between the two scenarios between EU-wide. So the same exercise we did for Portugal, this would be for EU-wide. If we keep the 2,000 schools open, or if we allocate schools in 2035. And here you see again the trade-off coming up, where you could have more changes in expenditure if you don't affect your network, therefore not affecting so much the distances. Or if you go for an efficient allocation, will lead still to changes, but less proportional than in the other case. The question, of course, is that these two types of changes do not come from the same source. Probably expenditure changes are going to be borne by governments that finance primary education, whereas changes in travel costs are going to be borne a lot of the time by families or students. So it's an interesting question on how governments are going to balance this. And I stop here, so because I really want to hear your questions and comments. Thank you very much.
Thank you very much, Anna. That was an excellent presentation. I've been having some private chat with Levi, so I know that we have lots of questions, but I encourage the participants, the audience, to submit their questions on the Q&A. One of the questions that I had, Anna, was actually about the transportation costs and sort of whether we hit a threshold. Well, I have a lot of questions. One of them is about transportation costs and whether we hit a threshold where that is then a cost that has to be taken on by government. That when travel time to schools is shorter, then it's assumed that households take that on. But if it's longer, then. But the other question I had was about the decision to make schools bigger as opposed to making them smaller. So you could imagine sort of what we've done with other sorts of services in depopulating areas to provide sort of microservices for populations. Is that something that you thought about?
Yes, so about the travel time, actually, we did a review of what kind of policies countries have, and this varies quite a bit. There are countries that finance the entirety of travel costs for students, others don't do at all. So, and it seems like these rules are very sticky. So it might be that they don't finance as much as they should. And as you see, it gets interesting in the extreme cases, which is like marginal difference for the last student with in terms of accessibility, how do they get compensated? And I don't think there is much thought about this equity question in policy designs for allocating this type of funds to students. It will be more like average kind of levels. So that's actually one of the things that we wanted to highlight here. About your second question, so if I understand correctly, you're talking about the collocation of services, maybe?
Well, you could, so a challenge when you have fewer students would be that you could increase the students per teacher because teachers are expensive, and then students travel further to get to the school. The other alternative is just to shrink the schools.
Yeah.
Right? And just have 1 or 2 teachers per village who probably have to cover multiple grades.
Yes.
Exactly. And then you have a bigger question, I suppose, about the quality of education that's being given.
Yes.
But I see sort of, as a non-expert, some policy advantages to taking that approach.
It is actually a very interesting question because there's a lot of research about the effect of school sizes on quality, and the answer is not straightforward at all. In many cases, small schools have proven to be even lead to higher performance. What we do know is that small sizes are not good for diversity, for instance, of curricula. So this becomes more important or complicated, let's say, for when you increase the educational level. So when you get to secondary schools, probably you do need to think about concentration in order to have appropriate diversity of curricula. We know also of policies of multi-grade classrooms, which are interesting. For instance, in the case of Italy, where they tackle this problem by bundling kids of different ages together. But another problem that we hear often is that the problem is not so much the teachers, but the school managers. So apparently small schools struggle a lot to have school managers that are on demand in rural areas, but there's not enough supply of them. And teachers necessarily cannot fulfill this function. So it's actually policies of, for instance, school clusters where you have satellite schools under one management that is, for instance, concentrated in a village, where you concentrate this management of the schools that operate in a sort of network. So that is one solution, but yeah, it's an interesting question.
Related to that, I did have a question about when you showed the table of increasing school sizes and suggested that it had heterogeneous effects in the type of habitation. It looked to me that the actual change based on the policy was about 15% overall for every group. But in some cases that represented a significant reduction, whereas in another case it was just cost containment. Is some of this more about the way that these kinds of changes are pitched to policymakers, where we might have to talk about cost containment for rural schools, but savings in urban areas? Or is it more about sort of pursuing larger class sizes in rural areas, whereas rural areas kind of have a savings that can be made, so maybe we don't need to increase the class sizes there? Is there kind of a geographical variation in policy that you're looking at?
Yeah, I think it is an interesting question because in cities I understand that then the quality question comes in, and it's actually not so straightforward, because even by migration alone, they will be facing higher school sizes, and this can be detrimental to quality. So then even if they're saving money, they might be sacrificing quality, then they might actually not go for the efficient sizes because they need to reduce it to ensure the same quality. In rural areas, I think the main issue is ensuring provision in the sense that maintaining schools open sometimes, is not only a matter of maintaining the staff of the school, but the building, etc. first. And that these rural schools may have more significance beyond the provision of schooling itself.
Yeah.
It's actually a very charged political question on when and how to close these schools. So I think ministries of education are more busy with that question, whereas the applicants say, like, you will save 2 pennies or 100 pennies in the future. It will be a matter of, well, this is a policy that we have to undertake. We know that we will lead to some savings, but then there are so many other elements to the financial questions that enter into play.
Yeah. We have
I have more.
go ahead.
We have more. I have more questions, but we have one that's come up here in the Q&A from Jing Zhang, who thanks you very much for your talk. And the question is, in a general trend of population agglomerating in urban centers, I'd imagine that in the left behind places, the aging of population will be more severe than urban centers too. So do you think it's possible to combine primary schools with, for example, caring facilities into a new kind of service so that, again, efficiency can be raised in these sort of hybrid service agencies, which I think is sort of the direction you took my initial question.
Yes, exactly. That is one of the policies that we are exploring, integrating services, multi-centers, etc. For education, we know the cases of multi-centers for different levels of education, where you combine it with boarding services for students, etc. This concept of multi-aging is quite interesting as well. I think, I don't know how easy it would be to implement it, but definitely we go in the direction of trying to use the facility of the school as a hub for other types of services. And here, for instance, there are very interesting cases in Canada where they have network schools that through digital technology actually expand the network of the school to include, for instance, museums, universities. So you might think also digitally you can expand the scope of the activity. But yeah, because of the specificity of the service for care for older people, it might be difficult, but yeah, something worth exploring.
We have another question that's come in from Daniel Arribas-Bell asking if there's room to change, and I think this is a very timely question, sad 2020 after all. Do you think there's room to change how rural schools work in terms of distance learning? And is that a sensible route to think? I'm thinking about lessons from education in the pandemic, etc. If so, how would that fit with your projections?
Yes, definitely. Yes. For our project, I mean, everything that happened with e-learning and the boost that it had, or the shock that was given to it, something very quite interesting to watch. What we worry mostly is that we see a very significant digital gap, both for students and teachers and even school managers. Without this component, you know, e-learning will not be as efficient where, you know, it can be, which is in rural areas. So now the question is about what kind of investments you make for tackling the problem of the human capital, let's say, of the skills problems. The technology as such, you know, has been around for a while, but this problem of the widening gap of digital skills seems quite hard to tackle. You might think of policies like, okay, expanding your pool of teachers by allowing teachers to be located in urban areas, teaching kids in rural areas. But then you would have to think how that would affect the outmigration from rural areas and the attractiveness of rural places. So these are not easy questions at all. We're trying to explore them in our report. But yeah, definitely that will be one component of the answer. The other one would be try to use digital technology for other innovative uses, such as like what I mentioned, belonging to networks or expanding the scope of school activities.
It's interesting too to think about how much creativity we've had over the last, I mean, now it's probably almost 2 centuries of this sort of emphasis that's been placed on provision of education by the state, and that it should be free and accessible to everyone under a certain age. But we used to send kids away to school. That was an acceptable way to handle education. Sometimes we put them on buses for a very long way, yes, each direction. Sometimes we have one-room schoolhouses. And I wonder just sort of how much creativity there was over the last century or two in sort of how to, this question of educational provision when you didn't have so many teachers.
Yes.
And it was more difficult to move around, and you certainly didn't have Zoom. Now we have the advantage of distance learning. But we
Yes.
actually, I think, have a pretty large suite of tools at our disposal to think about how we're going to handle this in the
Yes.
future.
That is very interesting, Rachel. And I think at the same time, there is a almost romantic attachment to the idea of the village school. You know, that is going to stay with people, at least for this generation. Even if you don't have any students to serve, they want to go around the Times Square and look at the school. And that part, you know, it doesn't go at the same pace as digital, and it doesn't go at the same pace as cities. So how people react in rural areas to the closure of schools is also an extremely important topic to take into account.
There's also sort of the path dependency of losing, because I know there's been some research on this in the German context of preschools, that you lose your preschool and it's basically like signing the death warrant for the village, because
Exactly.
who would move to that place if they were
Exactly.
thinking of raising a family?
Yes.
So it's very
That raises
challenging.
Interesting sort of dimensions when you're talking about optimizing for the 2035 distribution, right? When you're thinking about primary schools, both in terms of their location, but then also in terms of their feeding into secondary schools and how it sort of builds a cohort. It's a very difficult problem, I imagine, for the optimizer.
Yes, exactly.
It's also interesting how
a lot of the time they don't do anything really.
Yeah.
Pass the ball across, and they don't wanna deal with the topic. We see this a lot: institutional blocking and no action because it's too difficult. But something needs to be done. So.
Yeah. Well, this was fantastic. We're 2 minutes before finishing. I don't know if there were any last questions. I might give it another minute or so, and then we'll close. I mean, it's interesting to me just how integral schools are to the desirability of places. That in fact, they're such a core amenity that they're not even considered an amenity, really. It's just should be there. But once you start changing sort of where they're located, that could change a lot of behaviors.
Exactly. Yeah. And I think also the question of that any schools need teachers, when we see it from the point of view of the resources, is pretty clear. If you see in the numbers I showed, the decrease in the demand for teachers, that they will be much stronger in these areas. You already have a problem of attracting people there. You have declining demand. So are we talking about maintaining a building, really? If about the students and the teachers. So yeah.
Okay, well, this looks like a natural place for us to close. I really appreciate your coming. I'd like to thank also the audience for taking part and for the questions. If you'll bear with me for 1 moment, I'll share my screen again just to give you a sense of next week's talk, which will be next Tuesday, 4 o'clock UK time. Xunshen Zhao at University of Glasgow, who'll be talking about heat resilience and strategies for addressing that. So please join us. You can find information on all of the upcoming talks on our website at Newcastle University, also on Twitter, and we will be posting past talks on our YouTube channel. And with that, I thank you very much, Anna, and thanks to all of you. Have a nice afternoon.
Thank you very much. I enjoyed it a lot.
Thanks all.